Oh, actually, can I share my screen? Can you,
Sure. Oh, do I need
yeah,
to unshare here? How does that work? Stop share.
okay,
Boom.
great.
There we go.
All right, looks like we are up and running. Hey, everybody, thanks for joining. It's Paul here with our DOK Town Hall. I have Jérôme Petazzoni. We just
Hi.
went over the pronunciation. So yeah, thanks for joining us today. We have a great talk. Before we get started with Jérôme, I'm going to, as usual, do a few community announcements. So here we go. So yeah, of course, today we have Jérôme, 1 year in production with CloudNativePG and ZFS on the cheapest Kubernetes cluster we could find. So hopefully, I think we tried to get all the CloudNativePG enthusiasts here, but and hopefully some other people as well. But yeah, Jérôme is the founder of Tiny Shells, Shell. Oops, sorry, I have a typo there. Shell script and software engineer and developer advocate. Um, Okay, so some community announcements. I want to give a special thank you to our Platinum community sponsor, EDB. We really appreciate your sponsorship, which allows us to do these talks and other things with the community. And then I just wanted to highlight, this happened a few months ago, but DOK Day. Thank you to our DOK Day sponsors, event sponsors, EDB and Prefect as well. And to let you know, if you didn't know this already, all the recordings from KubeCon, but also DOK Day are available on YouTube. So if you weren't able to attend that live, you can scan the QR code that'll take you to the DOK YouTube and specifically the playlist for DOK Day in London. So yeah, check that out if you weren't able to attend. There's a lot of really great content. And then also coming up, of course, we have DOK Day North America, or at KubeCon North America 2025. That's going to be on November 10th in Atlanta, Georgia. The CFP is open. You still have about 2 weeks to get your proposals in. Here are the topics that we're always interested in hearing from you all. And you can scan the QR code. That'll take you to the page for DOK Day, and then you can submit your proposals. But yeah, we look forward to hearing all the interesting things going on in the DOK ecosystem. So make sure you get your proposals in by June 30th. And then, of course, each year we put out the DOK report. So we will be conducting the survey shortly, collecting data for the report, which we will hopefully have ready for DOK Day North America at KubeCon. So yeah, stay tuned for that. We'll be letting everybody know, putting it in Slack channels, LinkedIn, letting everybody know when the survey is available. Of course, the report is only as good as the data we collect. So hopefully all of you will submit your answers for our survey. And then upcoming event in July, we have for our DOK Town Hall, we have your object store is your vector DB, and that's with Yuval Lifshitz, senior technical staff member at IBM. So you go to our meetup page, scan that QR code, or you can just go to meetup and search for data on Kubernetes and register for that event. So that'll be coming up, of course, always on the third Thursday of the month, with the exception of this month because we are acknowledging Juneteenth, which is tomorrow, which is a holiday here in the US. So yeah, without further ado, I'm going to hand things over to Jérôme. But oh, sorry, one more, forgot. If you're interested in just learning more about the community, you scan the QR code on the left. I'll take you to the community page on our website. And if you're interested in sponsorship, of course, the QR code on the right will take you there. But now I will pass things over to Jérôme, who will be doing his presentation.
Yay. Okay. Well, let me do the traditional Zoom ritual where we try to share the screen and pray that it works. And hopefully, did that work? Because Zoom is only showing me like a black screen.
Right now, it's saying you start sharing your screen, but I'm not actually seeing the screen yet.
Okay, yeah. So like I said, the ritual where we try to share the screen and we hope it works, but sometimes it doesn't. Okay, let me try again. Share, system desktop capture. Yeah, that seems fine. Share, and What about right now?
Not quite yet. But
Interesting.
oh, there it goes. There it goes. Yeah.
Okay. Okay, great. Yay. Um, okay, well, I'm glad we did the traditional thing. We always feel like when people ask, "Can you see my screen?" I'm like, "Well, obviously, duh." But this time, this precise time, I'm glad we asked because otherwise, I would have started a presentation with a black screen, which would have been maybe a little bit less interesting. So, hi everyone. I'm Jérôme Petazzoni, or if I try to pronounce it the French way, Jérôme Petazzoni. And I'm here to talk about a kind of cheaper Kubernetes, running Kubernetes on the cheap. A couple of words about me. I worked for 7 years at a small garage startup called Docker. Maybe you heard about them. I worked there from 2011 to end of 2017, something like that. So I was running containers in production before it was cool. And nowadays I do consulting and training on Kubernetes. And sometimes I dress up as a pirate to go on stage at KubeCon, which was a one-time thing, but who knows, maybe we will be able to do that again in the future. When I'm not working with containers, I do music and tinkering. And for the folks really curious about it, in the slides, you can click on the link and you're going to see a really cool project about music and tinkering. By the way, you notice there is a QR code on the slide. If you scan that code, that's going to take you to the slides where you have like all the links and a bunch of extra informations as well. So today, it's a customer story where I am the customer, or more precisely, I'm helping that customer. That customer, between air quotes, is Ephemera Search. Ephemera Search is a passion project. Like my partner is working on that. It's a database of old mail. Right now, we have more than 2 million pieces of mail, like mostly postcards, but also telegrams, letters, and so on. So a little bit of technical data, like the database is about 200 gigs, which is, not too big. It's not tiny, but it's not huge either. We have about 1.5 terabytes of images, like scans of these pieces of mail. And the stack started as a really classic Django monolith. And then, the front end kind of branched out to React. And there are a bunch of workers. There is a little bit of machine learning inference to do some computer vision on the postcard and pieces of mail, like that kind of stuff. So it's a very modest stack. We are not talking about, unicorn billions of servers and so on and so on. And so what's the best way to host that? Well, if you look at that, like I'm sure many of you are going to think about, well, we could just put that on a PAAS, something like Heroku or Vercel or Fly.io, like something like that. And that's pretty much what we did for a while. So, we always talk about build versus buy. Am I going to build a custom solution, or am I going to buy a product that does that for me? And here, build would feel a little bit ridiculous. Like, I'm going to build like web servers and put some load balancers, and I want a database cluster for my Postgres database, and I need a image hosting service to deal with uploads, and also a CDN and image transformation, resize and so on. Or I could use a PAAS, and that's going to be way, way cheaper and way faster. So obviously, that's what we did. And until early last year, that was our stack. Heroku Postgres, Cloudflare Images, and for search, we were using Algolia. And I want to say we were super happy with that whole stack. It was great. Now, the Ephemera search, like I said, it's a database of old mail. So our target market is basically folks doing like genealogy and history, looking up stuff about their ancestors and trying to find, a postcard or mail that's been written a century ago by or to one of their ancestors. So basically, this is not, some super fancy, shiny AI blockchain agentic bullshit. So we don't have any investor money, which means that all the money that goes to host the project literally comes from our pockets. And when I say our pockets, That's these two people. So there is me and my partner, who's the true lead on that project. She's the one like kind of building everything on that, and I'm just helping a little bit with the infrastructure and as the occasional rubber duck. So if we look again at the build versus buy, sure, a PaaS hosting doesn't cost you much. Like I said here, it's maybe one like $1,200 a month, but it's every month. And when it's your money, it means every month you have to come up with about 1,200, 1 grand, every month, month after month. While if you build something yourself, and if you can find a way to pay less month after month, maybe it could be worth it. And most importantly, if you are a company, if you have to spend time to build something, it's engineering time that you spend and that you're not doing something else with that engineering time. But in our scenario, since we're both freelancers, contractors, when we have some time between two customer engagements, well, we might as well use that time to see if we can optimize things a little bit. So that's how we got started on that optimization project. Right, what we did basically, the big picture, and then I'm going to zoom on the different aspects, in particular on the database side. We moved from Heroku to Kubernetes, which usually would sound a little bit crazy because, Heroku is a really kind of simple, and I mean, simple in a good way. I'm not saying it's simple in the sense of like it's simplistic, but it's very easy to use. It has an amazing developer experience. So when you move to Kubernetes, like, how are we going to have the same convenience? Then for the database, we moved to CNPG and ZFS. So I'm going to spend a lot of time to talk about that. And then we also moved from Algolia to Meilisearch, and from Cloudflare images to Ceph and image proxy. But I'm not going to talk about these two because we could maybe have another talk in another meetup one day. But we also did that. So for the Heroku to Kubernetes part, even though at first it seems a little bit overkill, well, you have your Django monolith and you put that on Kubernetes, like really. But even though the website is fairly modest in itself and we honestly don't have a ton of traffic, that changed maybe like a couple of weeks every year. In particular, every year there is a conference called RootsTech, and RootsTech is basically the KubeCon for genealogy. So you have, I don't know, a few thousand people gathering in Salt Lake City, and like it's kind of the intersection between genealogy and tech. And we try to be at that conference and we meet a bunch of people. And of course, during that time, there is a lot of traffic on the website, so we need to scale up quite significantly. Now, even if the website is not so big, we have a bunch of workers and crawlers doing like retrieval of listings on eBay and analysis, et cetera, et cetera. And due to the fact that the eBay API is, I don't know, maybe 10, 20 something years old and has some very interesting and peculiar design choices, that means that when you have to interact with that API, that leads to more interesting design choices. And so, yeah, that whole crawler system is kind of way more complex than it really should be, but it's not entirely our fault. Like I mentioned earlier, we also have a little bit of custom machine learning stuff, not crazy Gen AI things or anything like that, but we have models to try to do some analysis on the scans of mails and postcards and whatever. Another thing that we wanted also is ultimately want to be able to kind of move the website more easily, because if you are on Heroku or Clever Cloud or Vercel or Elastic Beanstalk or whatever, you are absolutely locked on that platform, and moving is a little bit difficult. If we are on Kubernetes, in theory, we should be able to move to another Kubernetes fairly easily. We considered going on a single VM because honestly, for 50 weeks of during the year, the whole thing would absolutely fit on a single VM. Problem is that the SLA of cloud VMs is not great, and also the scalability is not great either. Some clouds let you resize VMs, but not all of them. Um, Sometimes you can resize only within some instance classes and so on. So like, okay, plus even if we go with a single VM, we still need to handle how do we deploy the software stack? How do we upgrade? How do we roll back and so on and so on? How do we manage the database in a nice way? And so even though this sentence is going to sound absolutely crazy, it was just easier to deploy things on Kubernetes for the reasons that I'm going to explain very shortly. So we did a quick kind of market analysis, and what came up, so I did some very quick benchmarking and like, okay, we need 3 nodes with 16 gigs of RAM per node, and we want at least 100 gigs of local storage. And so, I'm going to cut short the details of the prices here, but what you can see is that for what we want, we have kind of 3 tiers. We have like stuff like AWS, which is $600 a month. You have some, let's call them challengers like OVH and Scaleway. These are French providers, and they're kind of like half that price. And then you have Hetzner, which is even cheaper. So obviously, Hetzner was a really strong contender here. Just, out of curiosity, I also looked at other cloud providers, not all of them because I, have better things to do, but it's kind of really interesting that for that footprint, if you look at the big 3, Google, Azure, AWS, you have like between 600 and 700 per month. If you look at the challengers, Linode, DigitalOcean, OVH, Scaleway, it's kind of like half of that price and all like the same ballpark figures. And then you have Hetzner, which is significantly below that. Um, just a couple of words, because some people told me, hey, on AWS, it would be cheaper if you use reserved instances or spot instances. So yes and no. Spot instances would be cheaper, but for our use case, like including databases, that would not be a great idea. Reserved instances, also not great because you have to commit for a year and you have to commit on a specific instance type. And we absolutely did not want to do that. And even if you do spot and reserved instances, you still end up being more expensive than the competition. So why even bother? Now, one big downside of Hetzner, who's kind of like our favorite here, is that they don't have a managed Kubernetes offering. So that means you need to set up your Kubernetes control plane. And at first we thought, no, that's just too crazy. We don't want to do that. But then, you look again at the price and you remember that every month it's money coming out of your pocket. And like I said, we're freelancers. And so if you have a week available between 2 customers, you're like, hey, maybe I could teach myself how to deploy Kubernetes on that Hetzner thing and see how scary that looks. Then we had the next big question, which is how are we going to run the database? And the idea here is that, of course, we want replication, we want backups, we want something nice, and so we went with CNPG. And I'm going to give you the really short version. If you're a developer using Kubernetes, so if you know how to write YAML manifest and deployments, and you need to run a database on Kubernetes, then you don't know it yet, but you actually are a DBA because you can install CNPG on your Kubernetes cluster. And then if you need a production grade Postgres cluster, CNPG will help you with that in a way that, 5 or 10 years ago, I would have thought this is science fiction. So what does it look like? Well, so the same way that you would have a YAML manifest to run some microservice, you have a YAML manifest to run a Postgres cluster. So that looks like this. You say, hey, I want a primary and a replica, give me 100 gigs of storage. You apply that manifest, and literally 1 minute later, less than 1 minute later, you get your cluster, primary, replica with automated failover and so on. So that's pretty great. It's blends super well in the Kubernetes ecosystem. It kind of follows a bunch of conventions and best practices. So for instance, if you want to wait for the cluster to be up, sorry, you can use kubectl wait. If you do kubectl get clusters, it's going to show you a bunch of things about the state of your cluster. I'm not in the right namespace here. So if you do kubectl describe, it's going to show you a bunch of things as well, and so that's super convenient. There is a kubectl plugin that helps with a bunch of these things, and there is also a lot of little details. The little details that you don't notice at first, but in day two operations, you're like, oh, thank you. So for instance, when you drain a node in Kubernetes, so something you do typically when you're going to do a maintenance on that node, CNPG is going to kind of detect that. It's like, you're draining that node. Well, technically, it's going to detect the cordon, so the thing where you say, hey, don't start new stuff on that node because it's going for maintenance. And if there is a primary of like a primary Postgres server on that node, it's going to switch over so that when that node gets shut down, none of your applications are going to be impacted. So it's little detail, but like very, very nice, very convenient when you do cluster maintenance, cluster upgrade, and so on. I have made upgrades on the Kubernetes cluster, upgrading the nodes one at a time without giving a single thought to the workloads on the cluster, and that did not affect the workloads on the cluster thanks to these little details, basically. Um, Also, I would like to mention that the CNPG documentation is absolutely awesome. And I think documentation is at least as important as the code of a project. I know this might seem a little bit controversial because often we think, well, the code has to be good, right? Because if the code sucks, then like nobody will want to use the project. Well, I have kind of sad news. If the documentation sucks, nobody will want to use the project either, because when they try to do anything, they can't find the information in the doc, and so the project isn't going to be successful either. So in the case of CNPG, the code seems to be good. I say seems because honestly, I haven't audited that code myself, and I don't think I would be in a capacity to be able to cast a judgment on it. But it seems to be stable. We didn't have any bad surprise with it. So the code seems to be good. The doc is definitely great. The project is also fairly active. You have like new versions fairly regularly with new features, and I wouldn't be able to tell you what's new in the project because to be honest, I'm not following from super close like the status of the project. But yeah, I see new stuff coming pretty regularly. And I'm trying to open the Zoom chat, but Zoom is doing something super weird. When I click on the More button, the menu opens but closes immediately, and I can't click on that. So that's kind of annoying. So I'm not able to see what's happening in the chat because Zoom sucks.
Oh, well,
Um,
I'll tell you, it was just me saying I agree about the having good documentation and being
awesome.
important.
Okay. Okay. So yeah, great docs. And like if you, so first, as you can see, I'm very enthusiastic and happy about CNPG itself, but there are also other operators. And I was joking about the fact, like in the beginning of that talk, that I like to dress up as a pirate and go on stage. And so we did that last year at KubeCon. And so there is a link to that talk here where we compare multiple database operators, so that can also give you an idea of how they compare to each other, basically, and the bigger picture of how they work, what they do, and so on. Okay, so we have this great operator making it super easy to deploy a database cluster. Are we ready, to go to production? And obviously the answer is no. No, because we're missing backups and we're missing resource requests. We're also missing observability, but we're going to talk about that later. So adding backups. Well, so at the beginning, we had the YAML manifest on the left, and now we also have the continuation on the right. So what we have, we have for the backups, basically you say backup to that particular S3 bucket. If you want to use an S3 compatible thing, you specify the endpoint URL, you put like keys and so on, and that's it. Then you automatically, it's going to do full database backups at regular intervals plus log shipping. So you can do point-in-time recovery and things like that. Little details, these things save you money because I think by default you keep like 30 days. So here I'm like, hey, 15 is probably fine. And also compression is important because that's going to help you cut your S3 bill by a pretty significant factor. And this is to indicate how much CPU and how much RAM you want to have. This is more like a Kubernetes thing. When you run anything in production on Kubernetes, you absolutely should have requests for CPU and memory. That's really important for the Kubernetes scheduler to do a good job. Okay, so once we have that, are we ready to go to production? And no, still not, because even though we have backups, if you have backups, but you never tested them, then I have sad news, you don't have backups. So how do we restore things? The big picture here is that you provision a new cluster and you add these 4 lines here. You say recover from a specific backup, and it's going to provision a new cluster and restore there. And you can also do some pretty nice stuff like give a recovery target, which, if you, for instance, if you did a big whoops, let's say at 3:42 p.m. I dropped some production table. Well, you can restore and you can say restore to target 3:41 p.m., like 1 minute before, and it's going to restore and then replay the logs up to that point. So just before you did the big whoops drop table thing. So that's really nice, and that's all there is to it. It's to be clear, you could already do that before with Postgres. CNPG in itself is not it's not adding that to Postgres, but it's making it ridiculously easy to use, so that you don't need to be, like a black belt, 10 years of experience, senior Postgres DBA to do that stuff. Okay, you can also restore directly from backups living in a bucket or whatever. But anyway, okay. So we have a cluster with a primary and a replica. We have backups. We have tested the backups. Are we ready for production? Sort of, perhaps, maybe. Now, what are we missing? Well, we need to decide where the data is going to live. And it's kind of complicated because if you drill down, you're going to see, there is, you can specify where I want to put the storage and where I want to put the WAL, the write-ahead log, and there is also a volume snapshot. And it's all about storage classes. So what are storage classes? Well, on Kubernetes, when you want to create a volume, the most common way to do that is to create a persistent volume claim. A persistent volume claim is a way to tell Kubernetes, hey, give me a 50 gigs volume with that particular class of storage. So for instance, this is from a Kubernetes cluster on OVH, and it comes with like 3 CSI Cinder storage classes, and I added a local path storage class. On our production cluster, we have these 2 storage classes, which are Edge Cloud, so that's the one like the EBS equivalent at Hetzner, and we have the ZFS one. So basically, you have to indicate which storage class to use, and so of course, one of our questions was, well, what should we use here? So I did some very, very rough benchmarks. And to be clear, my goal here was not to have, scientific benchmarks, but more like a relative comparison, like to see if one particular storage class would be so much faster or slower than another one. So that's the results on a Kubernetes cluster on OVH. And okay, so some stuff kind of makes sense, like their old style stuff is a little bit slow, then their new style stuff is much faster, and then they have a faster thing Gen 2, which is kind of weird because it's not faster than the previous one. And then the thing that at first kind of broke my brain a little bit is that local storage, on the instance local storage was much, much, much faster. You can see like this is transactions per second on my very simple basic benchmark. Like why is that? Why is local storage on the instance, which traditionally is this kind of like crappy local disk, why is it faster than supposedly the crazy fast SAN remote storage that the cloud is using? And well, this is because basically of these things. Like these things are NVMe disks. And 10 years ago, you would have shown me this. I would have said, "Oh, that's a RAM stick," except they put the pins on the wrong side. But no, that's a disk. And NVMe is super fast and super cheap. So basically, I just for fun, I did an experiment. I was like, okay, what's the fastest, cheapest NVMe you can find? And I found one which was sub $100, and for 1 terabyte, it was doing almost 1 million IO per second. And 1 million IO per second, like 10 or 15 years ago, you would have had to pay like crazy amounts of money to get that. And now it's just like this little stick here with that completely unknown brand, by the way, like Fiquat. I'm like, I don't even know where that's come from. But super cheap, crazy fast. So great. Now, local storage has some pretty significant downsides. First, it's local storage. So if you lose the instance, you lose the storage. Oops. Also, if you use the local path provisioner I was mentioning, when you create a volume, all it does is create a directory. So there is no, limit on the size of the stuff in that directory, no quota. You don't have snapshots, nothing like that. And of course, in terms of scaling, since it's storage on your instance, like on your machine, you can only go as big as what you can put on the instance, and often it's not a lot. So let's see how to address that. Well, first, the fact that the storage is not durable. If you have database replication, you don't care. Like, oh, I lost an instance. Well, anyway, it will automatically fail over to the other instance, and you're fine, like immediately. Now, what if you lose simultaneously the primary and the replica? Still no big deal. You have backups and you can restore from your backups. And so, sure, you're going to lose maybe the last segment of the WAL, the write ahead log, but you're not, completely screwed. Next, in terms of features, even though the local path provisioner is pretty limited, we have other provisioners, including the OpenEBS ZFS local PV, which, as we will see, has a bunch of features that are super interesting for our use case. Okay, and then finally, in terms of scaling, because some folks told me, okay, the cool story, but what if I have a 10 terabytes database? How do I put that on local storage? All I can see on my cloud, the biggest thing they can have is maybe like 1 terabyte or something like that. So what can we do? Well, a couple of things. First, if you are unfortunately stuck, with the big three cloud providers, they often have instance optimized instances. And just as an experiment, I looked at how much would I have to pay to get an instance with at least 1 terabyte of storage. And on, on EC2 and Google Cloud and Azure, it's about 2 grand a month. So it's not cheap for sure. But the interesting bit is that if you want to go that route, and like us, you're like, hey, I want to go cheap and I don't mind putting a little bit more work, you can get a dedicated server. And sure, a dedicated server, it's not very cloud-like. You're not paying by the hour, you're paying by the month. But if it's a 10 terabyte database, you're probably not going to be spinning it up just for like, 3 hours or 2 days or whatever. If it's your production database, it's going to be up all the time. It's not something that you're going to be like scaling up and down with auto scaling or something like that. And then if you look at the providers I was mentioning earlier, if you want at least 10 terabytes, it's way cheaper. See, like 200 euros, 300 euros, $300. And often you actually get a little bit more than 10 terabytes. I just took the first thing I found on their price list that was above that, and that's not just for the storage, but you also get a pretty beefy server with that, with I don't know, like 16 32 cores and 64 gigs of RAM and et cetera, et cetera, et cetera. So that's something to consider. Now, I was talking about ZFS, and I'm going to explain why it was kind of key for what we're doing as well. ZFS is this file system that initially comes from Solaris, and it has a ton of super amazing features. So, for instance, transparent encryption, compression, deduplication, copy on write, which means snapshots and creating clones from snapshots. You can transfer snapshots from a machine to another in a very optimized way. And even though it was born on Solaris, it's also available on FreeBSD, NetBSD, Linux. On Linux, you have a kernel version and a fused version, depending on if you have like specific deployment constraints or whatever. And it's been around for a while. It's not like this shiny new stuff. It's been around for, I want to say, decade and a half, maybe a little more. And on Linux, installing it is very streamlined. Yeah. So, for instance, on Debian and Ubuntu, you literally install a couple of packages, and that's it. You're good. And on Kubernetes, we have this OpenEBS local PV ZFS thing, which helps us leverage ZFS. So I'm not going to talk about the install process and ZFS demos and so on, because I actually already made some talks about that. So I just put links there. I also have a repo with a bunch of scripts and demos and so on. But after you install ZFS and you make some benchmarks, basically what you can see is that, so here I made some tests on the Proxmox lab, because that way I could access a SAN, and I tried different ways. And basically, the bottom line is that ZFS is almost as fast as the local storage. And it's faster than the SAN and whether you access the SAN, in that case, it was with iSCSI or as an NFS client. So some little details here. So remote disks are going to be slower. And even if you get like a really crazy expensive SAN with super nice disks and so on, well, the problem is that you're going to have the latency between the machine and the SAN. And even if you're on, 100 gig Ethernet or fiber channel or I don't know what, that's still going to be way higher than the latency over the PCIe bus used by NVMe drives. So local NVMEs like this, even super cheap, crappy ones, are going to be faster than this SAN, at least in terms of latency, which helps us a lot. And so ZFS is going to give us the kind of features that we were lacking with local storage. And why is it a little bit slower? Because at first we're like, wait a minute, you were just kind of pitching ZFS as this super awesome thing. So why is it not the fastest one? Well, because all the nice features come at a cost. And there is this very kind of simple explanation. Like when you write something on ZFS, instead of just writing the data and done, you write the data and then you have to update the tree of blocks. And at the end, you have this atomic update of a single block, and that's what guarantees that if you have a power outage or something like that, you're not going to lose data, or at least you're not going to corrupt your data. And that's what guarantees that you can have atomic writes, which are pretty important for databases. So that's why it's a little bit slower because of these added features. But as you can see, it's not super slower, so the difference between ZFS and ZFS CNPG here, this is kind of like with the default settings, and this is after doing a little bit of tuning. And I'm going to be honest with you, I don't remember what we tune here. I think there is a little bit of compression setting, maybe the record size, but trying a few different parameters, and then we are pretty close to the performance of local disks. And we could probably do better, because I'm going to be honest with you, I don't consider myself to be a ZFS expert. I know how to set it up and how to get it to work, but that doesn't make me an expert on that. Okay, snapshots, right. Couple of words about these snapshots. Maybe you already had that scenario where you want to test a database migration, or like a pretty big change in your database schema, or some query. You're like, oh, I'm going to do this big update on a bunch of rows, and I hope I'm not going to screw up. So normally, you would take a backup, and if things don't go well, you can restore from the backup, or maybe you take a backup and restore on the side and try on the clone, and see what happens. But that takes time. Just to give you some numbers, when we did that last year, the database was about 150 gigs. So creating a full backup with a SQL dump and loading from a SQL dump, that would take hours. Now, using a PG-based backup, which to simplify is more like taking a tarball of the files and restoring with that, that would take maybe, like, I don't know, 15, 20 minutes, like way, way, way faster. And with snapshots, you don't count in minutes, you count in seconds, because you take a snapshot and that's almost instantaneous. And then when you create a clone from that snapshot, it's also almost instantaneous. And then you can, make your test, poke around, and if it doesn't work or if you screw up, it's okay. You can very easily create a new one and try again. So that really changes things a lot there. Same thing if you want to play around with, hey, what if I create this new index and see if it changes the performance or whatever? You can do all that on a clone. That's pretty convenient. Okay. Um, Now, there are many other nice features with ZFS, transparent compression. Like concretely in our use case, the database like today is 200 gigs, but it's using less than half of that on disk. Well, and it makes a lot of sense, because the way that Postgres stores data on disk compresses really, really well. And again, it's not a huge difference, 100 gigs, okay, whatever. But it happens that on the machines that we're using right now, again, we're cheap, so these machines have 240 gigs of local storage. So if we were using 200 gigs, we would be like pretty close to that, and we would have to be a little bit stressed out. But now, no, we are just using 100 gigs, so we know we still have plenty of breathing space before we would have to switch things up. Observability. So we're using Kubernetes stack. It's great. It's basically a kind of combo Helm chart that install Prometheus plus a bunch of exporters plus Grafana and a bunch of basic dashboards. And then you can start, like poking around and create your own dashboards based on that. One thing, which I'm going to say kind of bad news, you will have to set up your own observability dashboards. As you start to have either performance issues, or you want to set up monitoring and so on, you will often have to set up your own dashboards to show precisely the thing that you care about. And I don't know if I have I'm not sure if this is going to, no, okay, that's not going to work right now, but maybe like this. No, okay, fine. If I have some time at the end, I'm going to show you the Grafana stuff. So if you, like us, are working on a really tight budget, Datadog also has a free tier that can be helpful. It's pretty limited, maximum 5 hosts, and I only 1 day of data retention, but it's free, so it can still help a bunch. So there are many things that we could, mention but with ZFS and CNPG, there is a lot of tuning that you can do, emphasis that you can do, but that we haven't done because we didn't really need to. The performance that we have on the database now at least exceeds what we had on Heroku Postgres. So we're like, this is fine. There is also some pretty nifty stuff you can do with the snapshots. You can use ZFS send and receive to transfer a snapshot to another machine, and then you can, take successive snapshots and kind of transfer the diff between that, like many cool stuff. But I'm not going to talk about that. I'm going to give you instead kind of our conclusions. So if I recap. What have we done? What have we picked? How are we deploying things? We picked Hetzner because they were like super cheap, and we didn't see any red flag whatsoever. However, that meant deploying the Kubernetes control plane ourselves, which at first seemed a little bit scary, but we used that project called Hetzner Key 3S, which is specifically made for Hetzner, and makes that super easy and also like super fast. The project is really impressive. In literally a couple of minutes, you get your cluster up and running. You define your node pools. It's like a really nice shortcut. Um, then the part that was a little bit trickier was to automate the ZFS setup. At first, I was doing that kind of manually, connecting with SSH to the machines and installing the ZFS packages. And I was like, nah, that's not going to scale very well. So I instead now I'm using a custom CloudNativePG script to just install the packages and create the ZFS pool for us. So it's really streamlined. To deploy what I would call like the core workloads. So we do that with Terraform and OpenTofu. And the application workloads, so the Django monolith and the workers and so on, that's with plain YAML manifests. No GitOps, no Flux, no etc. And we have this idiom in French which says c'est les cordonniers les plus mal chaussés, which translates like the shoemaker has the worst shoes or something like that. Because even though my partner and myself, working on that project, we're both like consultants and freelancers, literally building that kind of stuff for our customers. For ourselves, for that application, we still deploy with plain YAML manifest just because it's good enough for our needs. So why make it more complicated? So 1 year ago, when we went to production, that's the cluster we had. So 3 tiny nodes for the control plane, 3 worker nodes. Everything was on there, prod, pre-prod staging, the database, and we had a few external services. 1 year, actually, 13 months later, we're still super happy with that, like absolutely no regrets. And we're trying to think about what we can do to kind of like push the envelope even further. How can we have something even cheaper? So what we did is that we moved from Cloudflare images to EMG proxy and Ceph. We have Enix. Enix is not the people making Final Fantasy, another Enix company, but that's the company in France with whom I do a bunch of my Kubernetes and Docker trainings. And they helped us by giving us a pretty generous bucket on the Ceph cluster. So that way we have images there. And for the search, we're using Meilisearch, which required us to add a little bit of capacity to the cluster, but that was totally worth it because I think our Algolia bill was maybe 500 a month, and the extra node on the cluster cost us 30 or 40 bucks. So totally worth it. Now, okay, the big question, because the whole thing, was build versus buy. So we are building it, we're running it. So how much extra work does that represent? Well, I'm the one taking care of the cluster, and basically every few months, when I see like a worrisome CVE on Kubernetes, like, oh, you should upgrade because there is something in the API server. Well, then that's basically when I upgrade Key3s. It's super easy to do. You can either do it kind of by hand, you just have to replace the Key3s binary and restart, or there is also some kind of like upgrade plan thing, which I used a couple of times. But that's going to, honest and a little bit embarrassing, but it takes me more time to remember how to write the YAML for the automated upgrade than to go and replace the binaries myself. So usually I just go to the nodes and replace the binaries, do them one by one, check everything is fine, and it's fine. Now, did we have any outages, issues, data loss, etc., etc.? Well, first, no data loss, knocking on wood, so that this continues. Now, outages. So in 1 year, we basically had one weird kube API outage that did not impact, like production traffic, because on Kubernetes, your control plane could be down, but everything will still work fine. And we just had to restart the API servers, and the problem disappeared. And I'm going to be honest, I could see also a lot of requests coming on the load balancer up front, so I wasn't sure, was that the kind of denial of service attack, or maybe we were doing the DOS ourselves because one controller was going crazy or something. But just restarting the API server solved it, so I guess that's fine. Um, and we actually had one production, like real production incident. We were down for maybe 10, 15 minutes because at some point there was a pretty serious vulnerability in Ingress Nginx, and the fix introduced a breaking change. And so when we installed the fix, that took down production, and basically we had to put an extra value in the Helm chart to fix it. That was, not the end of the world. Of course, it's not fun when you apply a security patch and it takes down production, but it only took like, 10, 15 minutes to go back online. So the bottom line, are we happy? I try to find a picture of a happy cat, to contrast with the cat saying no and the cat saying yes. But as it turns out, cats are kind of assholes who are never happy. And I could not find a picture of a happy cat. So instead, you get a picture of a happy dog, because finding pictures of happy dogs is really easy. I don't know why. Anyway, so just to do a recap of the cost difference, because that was the main driver here. Before, so basically in February, March of last year, we paid about 1,200 a month for infrastructure, IaaS, PaaS, like all hosting costs, and now it's about 150. So it's not exactly divided by 10, but it's pretty nice. We did a brief experiment on EKS because at some point we managed to get, I think, 1 or 2 grants of startup credits on AWS. And well, we blew through them in basically a month, and that was kind of way faster than we thought. So the bottom line was, well, don't use AWS unless you have lots of money, I guess. Now, of course, what could be better? What do we want to improve? First, we have a Melee search, so that search thing that is using tons and tons and tons of RAM. Basically, we had to kind of dedicate a node to it. And I'm going to try and show you the Grafana anyway, if I can very quickly conjure it up. I think I just need to get the like this. And yes, awesome. So just so you can see what will what our Grafana looks like for this little personal project. Like I said, you kind of build your own custom dashboard, because the dashboards that come with Kubernetes Stack are, they help, but they don't answer your questions. So here, for instance, I wanted to be able to see which pods were using the most RAM, to be like, hey, like that's this thing we should put some efforts into. And the big purple one on top is Search, so the search engine. Now that blue one here, that's actually Prometheus. Okay, so I hadn't noticed that before.
I've lost audio for a second. It seems like maybe your headset.
Sorry about that. I
Oh,
think my headset turned off because there was no sound coming. That's an interesting bug. Apparently, that headset didn't realize that I was not speaking to myself, but actually to an audience, and that shutting down was a bad idea. So yeah, for instance, it's great that I'm doing this talk today because I can see that I should probably have a look at this Prometheus pod because 7 gigs seems a little bit high. It's probably because we ingest more metrics than we should, and maybe we should drop some metrics to reduce that memory usage, for instance. Um, what other things we have? We have something very specific here. That's the disk activity on that melee search, because we realized pretty quickly, okay, that one is going to really, how do you say, kind of, it's going to be really bad on the storage. And so in yellow here, you have the reads. In green, you have the writes, or the other way around. No, that's the other way around, my bad. And so ideally, if we have enough RAM, the reads should be at 0 because everything should fit in RAM, and that's when things are really fast. And so here we see we have a little bit of reads coming in, so that's not great. And that also shows like how busy the disk is. So, that's kind of, I don't know if I would say weak spot of the whole stack, because even with these restrictions and constraints, like ideally we would give more RAM to Melee Search, but even with maybe half of what it should need, it still performs well enough for us. Now, how can we go even cheaper? Maybe self-host. We have a Proxmox lab with a handful of nodes. The problem is that we have a pretty frequent power outages where that Proxmox lab is. And also we don't have, remote hands, like if you need somebody to reboot the machine or whatever. And the most critical moment is the moment when we're not home. Like when we go to that genealogy conference I was telling you about, that's the very moment when it's really important that things are up, and so that's the moment when you would need somebody home to fix things if something goes sideways. So we're not, we're not yet brave enough to move from Hetzner and just go on our local lab instead, but that would be pretty exciting to do. All right, so I'm going to wrap up. Well, first, I'll be happy to take questions, but mandatory. Usually when somebody delivers a talk, they work for a company and they're like, "We're hiring," but here it's kind of the other way around. I don't work for a company; I work for myself, and so I'm going to say, hire us. I do consulting and training on Docker and Kubernetes. So if you need someone to train your team, ping me on LinkedIn. And if you want someone to build, state-of-the-art CI/CD pipelines and MLOps pipeline and so on, AJ, my partner, who's the brains behind Ephemera Search, can also do that and will be very happy to help. Okay, and on that, I can try to get questions. Let's see if I can access the Zoom chat.
I
Nope.
can read it to you as well.
Sure.
So yeah, we have a question from Jakob Scholz, who says, does the ZFS on Kubernetes support the volume group snapshots as well, or only single volume snapshots?
That's a great question, and I don't know. Um, I know it's an important feature for some use cases because you need to take all the snapshot at the same time to ensure consistency, but I don't know. We haven't had that need because we ended up using a single volume for data and for the write-ahead log. So sorry.
Okay. Well, it's by the way, I forgot to mention, I didn't realize when we met earlier that you were the person who gave the talk in a pirate's suit, and I was at that talk. That was a great talk. So just wanted to say
Thank you.
that out. That's funny. Well, yeah. So I guess I have a question. So, what are the lessons that you learned going through this process, and is there anything that you would have done differently? I know
Sure.
gave some examples of what you might change, but what are like the main things you learned from this past
Uh,
year?
I think a big lesson, which the year in itself is more a kind of a validation because the whole thing about you have the knowns and the knowns unknowns and the unknowns unknowns. And so here we really didn't know, okay, what's going to happen. Maybe at some point performance is going to start to degrade and we won't understand why and we'll be like, what's going on? You never know. But we were feeling pretty confident, and what gave us that confidence? Like the big lesson was first, not don't be afraid in a way, because at first when I suggested to AJ, hey, maybe we should just host Postgres ourselves, like she looked at me like I just got bonked on the head and then she's like, no, we can't do that. That's not reasonable. And I was like, well, we really should look at CNPG. And in a way, I was like, okay, how can I convince her that we can, figuratively speaking, bet the farm on CNPG? And the way I did that, I used Kind. And with Kind, you can create a Kubernetes cluster running in Docker containers. So a little bit like Minikube. But the nice thing with Kind is that you can have a cluster with multiple nodes. You need a config file, but it's like, I don't know, 5, 10 lines of YAML, so it's really easy. So I created a Kind cluster with, I don't know, 4 nodes maybe, installed CNPG and created a cluster. And then I did a Docker kill on one of the nodes because I wanted to see how CNPG would behave, basically. And it worked. And it failed over, and I had this demo that I could deliver in maybe 5 to 10 minutes to basically convince a fellow engineer that this stuff works. And I could be honest and say, hey, I built that demo in, I don't know, maybe half an hour or an hour. I didn't have to plug in some magic values in some secret YAML file somewhere. This is just the thing, out of the box. And that was super helpful to convince, well, her, but also myself that, okay, we can go that way. I'm also extremely lucky because Enix, like the French company with whom I do a lot of work, like they do what I do with that cluster, but at a much bigger scale and for a bunch of different customers. And so, for instance, they have a case study which is kind of the complete opposite. Well, not in the sense that it's the most expensive Kubernetes cluster you could find, but they run, I don't remember the exact number, but something like 50,000 Postgres databases on a Kubernetes cluster with CNPG. And so that means they have also a lot of know-how and experts, and I could sometimes ping them, mostly for the ZFS stuff, honestly, like to have some guidance of not necessarily what are the best parameters, because in that domain, you always have to test what works for you. You can never expect that someone is going to give you, oh yeah, set the A size or record size or whatever to this value. No, it's like, you have to test different values and see what works best for your workload. But at least they could give me some directions, try to tweak this particular thing. Don't bother with that one because it's probably not going to change anything. So one of the big lessons was don't be afraid to try something that seems a little bit crazy at first. Um, the part that was absolutely unknown was for one-person team. What is it going to be like to maintain a Kubernetes cluster like this? and that turned out to go just fine. And same thing, I was like, well, maybe we're going to need bigger nodes, or maybe we're going to have like unexpected issues or whatever. And no, that was fine. Things I would do differently. Um, so I don't know if I would use Hetzner Key 3S, and that might seem weird because I think like what 15 minutes ago I was kind of raving about the project, being like this is absolutely awesome, super fast, and so on. But uh, the reason is in the name. It's Hetzner, so it's for Hetzner. So if I want to migrate somewhere else, I'll have to rework that.
Mhm.
And so if I had to do it again today, I think I would go with Talos because again, a year ago, Talos is this immutable distro. It's kind of it's really cool. And 1 year ago, I would have the same reaction that AJ had when I suggested to you to run Postgres ourselves. Like I would have thought about Talos. No, this is like way too complicated and way past what do you say way past my pay grade or something like that. But since then, I've done a bunch of labs and tests and again I pushed the envelope with it. And now I'm convinced it's probably the best way to run Kubernetes clusters. Um, Oh, and of course, there would be some really interesting challenges to get all the ZFS set up and the partitioning of the disk, etc. But in the long run, I think it would totally pay off. And I think today, if I had to do that again, I would instead of Hetzner 3S, I would use OpenTofu, Talos, and I think the result would be something that's easier to deploy somewhere else. Yeah,
Sure. Yeah, I mean, yeah, I think those are, I think, the types of lessons you can only really learn from doing, right? So, um,
absolutely.
yeah, cool. Well, I guess I just have one more question. Well, like, would you recommend other people do this, and who's the most appropriate for this, type of setup?
Um, Well, the biggest caveat is that when we went that way, both AJ and I were not scared about the Kubernetes part.
Hmm.
Like working with Kubernetes, yeah, fine. I'll kubectl YAML all day. Now, the CNPG part, the ZFS part, that was a little bit scarier. But when you're already, how can I say, when you're already kind of steeped in the Kubernetes ecosystem all the time, picking up on CNPG and even the ZFS part like that was really straightforward. So would I recommend that to someone else? I would say, well, if if you're not comfortable with Kubernetes in the first place, I wouldn't say, oh, self-host your stuff in Kubernetes because that's going to be painful, like no doubt. However, for somebody who's already working with Kubernetes, even if it's not at a super high proficiency, but somebody who knows how to generate some YAML manifests and apply them and maybe they have some GitOps, maybe not, because like I told you, we were not using Flux or Argo or something like that because we wanted to keep things relatively simple in some way. I mean, sometimes we made complicated things, but we made them because it was saving us money, basically. And in our case, Flux or Argo would not save us money. It does save money when you're a big team and you want to force everything to go to a single source repo and you want like good auditing and history of all the changes and so on. But for us, that's not super important. Um, so would I recommend people to do that? Yeah, if they feel comfortable with Kubernetes, then by all means. If they don't, maybe there would be other options that might be easier to tackle. But when I say be comfortable with Kubernetes, again, it doesn't mean 10 years of experience and I have all the certifications and etc. It's literally like can you create a deployment, expose it with the service, and do you understand how labels and selectors work? And I think if the answers are yes, then you're a good candidate for that kind of stuff.
Okay, awesome. Sorry, I said last question, but I have one more. Are these, because you have a bunch of links on these slides, is there somewhere where people can access these slides? And if so, I can add it to the
Absolutely,
chat.
absolutely. In fact, the QR code in the corner here.
Ah,
So if you, okay, I'm trying to think. Since I can't open the Zoom chat, I can't paste something in the Zoom chat.
you know, you can e
Uh,
email it to me and I will add it in the notes for on YouTube. Then people can access.
awesome.
Yeah,
I'll do that.
cool. All right. Well, thank you so much. I think it's super informative for me and for a lot of other people. I'm a little disappointed that you weren't wearing a pirate outfit now that I knew that was you, but maybe the next time we have you on.
Well, I had my data on Kubernetes t-shirt, so I
Sure,
guess we need some kind of like crossover between the DOK and the Pirate franchise.
sure. Maybe
Pirate on,
we'll have to get you an eye patch with a DOK branding on it. So,
yeah, awesome.
all right. Well, yeah. Again, thank you so much for taking the time to put this together. Really appreciate it. And yeah, this will be available on YouTube, so you can rewatch if you want. And like I said, I'll add the link to the slides there. All right.
Thank you so
Well,
much.
yeah. Thanks. Have a great day.